Hello everyone, now I am going to explain you about a hardware implementation of an addition and subtraction of sign magnitude data. So whenever if you want to perform any arithmetic operations, who will take care of that? An arithmetic processor. An arithmetic processor is a part of processor unit that executes all arithmetic operations. So what do you mean by an arithmetic operations? It consists of an arithmetic operation. It consists of an arithmetic instructions. So in an arithmetic instructions, how the data is represented? So the data is represented either in the form of a binary or a decimal data. So that binary or decimal data that may be in the form of a fixed point representation or floating point representation. So now here today we are going to learn about the fixed point representation for an addition and subtraction of a sign magnitude data. So here first of all we need to know what do you mean by sign magnitude data. Suppose here when we are going to take any value or when you are going to perform any addition of two numbers. So here we are what if you want to go perform any addition of two numbers. So what is the sum here? It will be 10 plus 2 is nothing but simply 12. Okay. So here at this time, so this is a only magnitude value. It does not contain any sign. So similarly here, suppose if you want to perform any sign magnitude data, so therefore what we are doing, we are only saying that it is a sign magnitude. So this 10 represents a magnitude value and this plus represents a sign value. So therefore here now we are going to design an hardware implementation for this sign magnitude data, and whatever the operations we are performing either addition or subtraction. So this therefore here, so in order to perform this addition and subtraction of two sign numbers, so here we need to take a to register in order to store these some magnitude values as well as sign values. So therefore here, so in order to perform addition of two sign numbers, so first of all we need to store that values in an some registers. Let us name it as register A, register B, and we are saying that those numbers are already signed. Means what? Here we need to take a one extra flip flop, so which carries a sign bit of A value as well as sign bit of B value. So therefore here we have a two sign numbers, okay, named it as as comma a, bs comma b, like plus 10, like plus 2. So here we have a two values. Then what we are going to do, we are going to perform an addition as well as subtraction operation. So therefore here, in order to perform that addition operation, so here we are taking a one block that is called as a parallel adder circuit. This parallel adder circuit is made up of half adders as well as full adder circuits. So therefore here parallel adder which performs a addition operation, and it is also connected with an complementer circuit. Here why we are taking this complementer circuit means here at a time we are going to perform here either addition operation or subtraction operation. So therefore here in order to perform this subtraction operation, so here what we are doing here we are simply taking the sorry, one's complement of the subtrahend value and add 1 to it, nothing but 2's complement of subtrahend. So 2's complement of subtrahend becomes what? Here we can also represent this subtraction like a minus b as a plus b bar plus 1. So what is this b bar? It is a, here we know a is called as a minute, b is called as a subtrahend. So how can we perform this subtraction operation? So by simply taking the subtrahend and adding a ones complement to it. So the subtrahend ones complement to it will be b bar and add 1 to it. So it will be a ones complement, add 1 to it, nothing but it will be a two's complement. The result is again added to the minute. It will call as a subtraction of a binary number. So therefore here in order to perform subtraction operation, what we are doing, we are taking a subtrahend value and we are applying a ones complement and we are adding a 1 to it, and the entire sum is again added to a minute value. So therefore here the 2's complement of subtrahend is added to the a value, it will become a subtraction operation. So here what is the main process here? We are taking a b register value and we are applying a one's complement to it, and we are again add 1 to it, and that is again added to a register. So therefore here finally we are complementing it, again we are adding. So therefore here we need to take a complementer which complements the b value, and here parallel adder simply adds the these two values. So therefore here this is the hardware implementation of an addition and fixed point addition and subtraction of sign magnitude data. So a register sign, b register sign, parallel adder, whatever the whenever you are performing any um, addition or subtraction operations, if you are getting any carry, so in case of addition only we'll get the carry. If you are getting any carry, that is stored in an extended flip-flop. Any overflow condition is there, that is stored in an add overflow bit. So therefore here the complement is connected with the mode control bit. So in this mode control bit here, if m is equal to 0, it will simply performs the addition operation. If m is equal to 1, it simply performs the subtraction operation. Now we will see that. So whenever m is equal to 0, so this control is in a off state. So therefore here the carry bit will be 0 here. So therefore here if it is 0, so therefore for a parallel adder we simply get the a value as well as b value. So adder will add simply a value, b value. So the sum will be, it will be a plus b only. The sum will be a plus b only. If any carry is there, that is stored in an extended flip-flop, and the sum is stored in an a register. So when m is equal to 0, it simply performs the addition operation. Similarly, when m is equal to 1, so here the mode control is 1. So therefore here the complement, this will be active state, and this mode control is applied to an input carry of a parallel adder. So therefore here if m is equal to 1, the carry in is equal to 1. So therefore here for a parallel adder we are getting a, we are giving input as a as well as here what is a b register, and b register is applied to a complementer. So here the m is equal to 1, it is in on means what, it will performs the complement of b. So the complement of b is nothing but b bar. So therefore for a parallel adder we are giving a value and a b bar value and a carry value. So a plus b bar plus 1. So this is nothing but simply an a minus b operation. So therefore here thus again if any sum is, the sum is there, that is stored in an a register. Any carry is there, that is stored in an extended flip-flop. So this is about the hardware implementation of an addition and subtraction of sign magnitude data of a fixed point representation. Now we will see the sum table, how the addition and subtraction is done.